थोड़े दिवस तो राहिले हम्म
So we will start in next 3 to 4 minutes. We'll start in next 2 minutes. Let few more participants to join.
So all of participants can message and they can raise hand and vote, right? Basically, they give a thumbs up.
Yeah, they can do that. They can do
Okay.
that.
Okay, I'll keep my phone on chat mode so that I can see those signs as well as read the questions, if any.
Yeah. So yeah, by the way, we will be taking the questions once you are done with your presentation. Is that okay, or you want to take questions in middle of the session? It's up to you. What do you prefer?
Yeah, I'll ask at a stage that do have any questions at a point, and
Okay,
then
okay.
people can ask that way. So we'll move it in sequence.
Sure. Okay.
Anyhow, at the end,
All
we
right.
can definitely take some questions which could be at a global level, also at something which is we missed. But I want to be some sort of interactive, not one way.
Okay, then you let me know. At that time, I will enable if we want participants to talk, so we will enable their mic because currently we have disabled it
Yeah, they
just
can.
to avoid any disturbance.
No problem. They can always put a question in text,
Yes,
and
yes,
we'll take
yes,
it
yes. That's
accordingly.
okay. Okay, now we will just start. Good evening, everyone, and I warmly welcome you all for today's Applied Materials Problem Statement webinar. This is part of India Hackathon 2026, organized a part of SEMICON India. Thank you all students and all the teams that are participating in the hackathon for joining us today. Brief background of the hackathon. So this hackathon um, is relaunched, or I'll say we have come up with this hackathon to provide India students uh, with the industry. The knowledge from the industry of semiconductor opportunity to work on the real problem statements given by industry partners like Applied Materials and KLA. So basically, this hackathon is organized by SEMI India, IESA, with Applied Materials and KLA as our industry partners, VIT Vellore as academic partner, and I4C as hackathon implementation partner. So today's webinar will focus on the problem statement presented by Applied Materials. In this session, we will help you understand the industry context, technical requirements, expected outcomes, um, and the evaluation parameters, submission requirements related to the problem statement. Before we start, few instructions for the participants. So, as just now we told you, like if you have any questions, you can put it in chat box. At the if required, we will enable your microphones. Currently, you are on mute status. Um, and now I take pleasure to introduce our today's speaker, Mr. Ayush Raina. So Mr. Ayush Raina has been associated with Applied Materials for nearly 14 years, contributing across algorithm development and application design. So he currently serves as the direct uh, manager at in the algorithm group of Applied Materials. So he's responsible for developing critical measurements capabilities, including critical dimensions, commonly known as CD, overlay, or other advanced 2D or 3D measurement capabilities. So with his extensive experience in semiconductor and the related domain, algorithm development, and application design. So he brings valuable technical knowledge and industry insight to today's session and to this hackathon. So he will be the subject matter expert, mentor, evaluator for the hackathon problem statement, which is presented by Applied Materials along with his team from Applied Materials. Um, thank you, Mr. Ayush, for joining today's session and uh, guiding our students, participants throughout the hackathon. And now I request you to start with your presentation. Over to you.
Thank you, Saurav, for the kind introduction. I welcome all, and so yes, so we'll talk about this problem statement today. Uh, I'll try to go very slow. We have 1 hour. I may not have these many slides. So we'll try to cover slowly each slide, talk about in depth, and see. You can interrupt me, you raise hands, or you can always give me a thumbs up vote when I ask that this is clear or not. So it will give us that I should go in deep in one of the sections, or it's everybody's on the same pace. Okay, so let's go. Uh, okay, yeah. First of all, I want to clarify and make sure that everybody has interest to it, that it's an image processing problem. We are not dealing with any device. We are not dealing with any semiconductor chip at this stage. It's a pure image processing problem, and we want you to try it and solve it. And trust me, it's a very good problem to solve. You'll learn a lot of about it, and it's a pure. You have very wide rules of tools available to you. You can solve it with pure mathematics. You can add some complexity by adding some classical methods. You can add deep learning networks also. Okay. So it gives you a lot of leverage from diverse background to try and attempt this problem. So now I want to give a context why this problem matters. Okay, let's see. I want to give a real use case where how you basically work with Google Maps today. So let's say in Google Maps, if you I want to search applied materials, you will if you type it here, it knows where to go and find the applied materials in Bangalore office. But now let's say I don't want to do that. I want to search it by my mouse alone. So what I'll do, I will first move towards south of India, then to focus somehow on Bangalore. Now again Bangalore bring in the center of my screen. Then zoom further inside Bangalore. Then again bring it in the center of the screen. And then try to find some area which is near to our office. Okay. And if you start seeing, I'm looking for area called Whitefield. And let's say it's somewhere that's Wafer Road. So if you see, I'm doing it with the help of mouse. I'm trying to center it. And then I'm zooming in. And at least I'll say that somewhere here is my applied material office. Okay. So now if you see, it took me trying to zoom in areas and trying to correct myself and then reaching to applied materials location. Similar context we will try to use in our domain because when we don't know how to search it at the right location. For example, today we are at one location and we have a plus sign. Okay. And this pattern is printed on die. So what is a die? Die, if you see on the left side, these are each die could be one of your chip. Okay. And so let's say in this case, we have a matrix of dies. It's a 3 by 5. So there are 15 dies and almost all of them will look same because they will cut down each one of them as an individual chip. But our problem is not about dies. Our problem is that we want to basically have one pattern plus sign and we want to go at the same location in another die, okay, to do something there. Maybe we want to measure something, we want to find some defects. So now let's say we have a zoom pattern plus sign and we took an image here and under a microscope like you see in my image, and then we want to take an image. We took an image, we are very successful, we star it saying that this is my reference. Okay, now I want to go to a same location in a different tile. That means I want to go on a different die and take the same image. I know what is the distance. Okay. I try to move to that distance, but there is a stage error. I'll talk about stage error also to explain you more. But eventually I reach to a different location. As a result, I'm grabbing at a different location. If I try to grab at this location, I will not find a plus sign. Okay. So what is the criteria? As a human behavior, like I showed in the maps, you will try to zoom out and take a bigger picture and see where the die is, and then try to zoom in that area and try to correct yourself and find the plus sign. Right. So this is how is the correlation between the maps part which I showed you, and show here. But in maps we did a multi-step approach. In this we are making it simple. It's a two-step approach. Okay. So you'll do it in two steps, and how you will do it, we will talk about it. So now let's see why this error comes. We'll spend at least 5-10 seconds, maybe at least a minute to understand like why it is happening. So generally, these wafers are kept on such stages. So if you see, these stages are moving and the microscope is fixed. So since your stage is moving on motors, you may have some errors in stages while the stage movement because due to vibrations, angles. So as a result, you will never reach to the same location. So you will have some error, okay, when you're moving between the dies. So in order to address that, this problem with respect to imaging, we have created for you, which we also face it. We have many ways to overcome this. This is one of the challenge problem which we have posed here, which helps us to figure out the right location. Are we clear in terms of the background, like why we actually need this problem? Okay, why this problem exists? Any thumbs up? I don't see anything on chat.
You can also use chat to put yes or no.
Yeah.
Yeah,
Okay.
thank you, Arpit.
Thank you so much. Okay, so that means we are going. If you're going this way, then it's much more easier for me to make it more interactive. Yeah, Sujata, you can type some. Sujata, you can type your thing if you have a raise your hand, or you can hold also on this slide. And for this slide, you can type it and enter it. I'll see that if things get clarified, we'll ask you again. Okay, you can still post your question. Increase the mic volume. How do I do that? Mic is, you don't have a speaker control. Is it clear for everyone else?
And yeah, it's quite clear. Um, Maybe Subhi, you can try increasing your device sound, output sound.
Why do we need to use an image classifier like we don't use LiDAR and X-ray mapping? Yes, we asked a question. So there are many ways of doing it. You're right, we can do with LiDAR and X-ray, but I'll try to answer this question differently. Just hold on for 5 minutes. Okay, we'll come to that. So now we are dealing with something called a SEM column. Okay, so now in SEM imaging, we can see it at nanometers level. Okay, and the X-ray methods, or you can say the microscope methods or laser methods, will not be able to give you resolution at nanometers, this 1 nanometer level. So as a result, we want to rely on SEM imaging method itself. And plus it is hard to change microscope. You have to move the same location under X-ray and then the back to microscope. So that's the reason why we want to keep it simple solution. Like you want to go to a place, have one microscope, figure it out by yourself with the same camera. You change the setting and do it. Instead of bringing too many tools, do it with one tool. Because then again, you have to calibrate between two tools. So, and there are methods to do different things, but we'll focus only on this type of problem. I think so. You have very clear. Arpit, wait for this. I'll explain you why it is only imaging problem. So now let's see. Now let's say my camera has two zoom levels. Okay, it has 10x and 100x. So at 10x, my image looks like this. If I zoom into a green area, my image will look like this, big. So when I say this is my image, this was my plus sign before in my image here. So this is my reference plus star sign. And I'm coming to this die, but I don't want to come to the wrong location. So I take a zoom out image at 10x. So plus sign is my 100x image. And over here, I want to take a 10x image. Let's see again. So this is my star image, which is bigger. I know this is how it should look like. And when I want to go to a different die, I want to take basically zoom out and take a bigger image and then find my reference here and then go zoom in and take an image. Okay. But as a scope of this, you're saying we don't want to take you go and zoom in image. We are taking it simple. I'm just giving you a background. It's why it is useful from industry point of view. Now we will talk only about the problem only. Okay. So now if you see, you have one reference image, you shrunk it down and search it in the bigger image. It's a pure imaging problem. You have an image below, you have such images, you see more samples. You're shrinking the pattern on the left, which is a reference star pattern, the star case, and you're trying to find the same pattern in the zoomed out image of some other location. Does it make imaging problem now, Arpit? You can give a thumbs up. You don't have to worry about the background which I gave. It's a pure imaging problem at this stage. Okay. So we have 10x, we have 100x. We keep on coming to it in coming slides also. Just remember 100x is a zoomed out star image and 10x is your wide search pattern, which is a big pattern you want to search here. And 100x is your reference. Whenever I use reference, it means a zoomed in very clear pattern on left. And right side is your search pattern where you want to basically wide search is like where you are trying to search it. Where Tony asked a very relevant question. Won't the wafer have same patterns? No, every chip is different. Let's say a memory chip would be different, a logic, a CPU chip would be different. Then architectures change. Every company, let's say Samsung, Intel, MediaTek, Nvidia, they would like to create their own design. So the chips will also be different. Yeah. Somebody asked that the pattern may be localized to die about multiple die one-to-one mapping, reference to one. Don't worry about wafer and die now. This question is, we have reached to a place, now we don't worry about die. Now it's only, I just gave you a background using a die so that you know that why this problem is relevant. At this stage, you can say, yes, it is repeating between different dies, but we are talking about two images here on. It can happen. But I told you the problem that it will never be at the center. It will be somewhere in the between corner. Let's say over here is also one more matching location. Okay. So now we will talk about the problem only, and we will not think more about wafer and dies at this stage. Okay. Shall we talk more about the problem now? Basically, how you want to work on the algorithm side. Okay. So if there are no questions, I'll proceed. So Nikhil asked something, but Nikhil is not clear. Okay, so now we want to zoom in, find the zoom in reference image in the search image as I talked, and then you tell us where exactly is present on this tile. So let's say it is matching here. You give me the center of this green box. So if this is 0, 0 on the top left, this is what you have to give it to me. What is pixel XY at which it is hitting, right? Let's say if it is having more than one repeated pattern, you give me something which is closest to the center. Okay, for example, if this is 0, 0, this is closest to center, you give it this one to me, not this one, even if it is matching. But I want something which is closest to center. Best match, then second is the close. If two of them have same score, give me the one which is closest to the center. Okay, let's talk more. We have tried to keep the problem very simple. Both images are 1000 pixel by 1000 pixel. Now the question is, why do you want to work with 1000 pixel by 1000 pixel? The reason being is we want to have work with such a bigger pixel size is because we don't want to lose information. If I make a 256 by 256 image, searching it inside another image which is compressed will be even harder with noise. And we also don't do it in industry. So we want you to work with images which we generate with 1000 by 1000 size. So now to simplify, we can say no, I will talk about it, Harish. Wait. So let me just finish this part first. So now you have I want to go here, and but let's say some people would like to understand in terms of pixels, some would like to understand in terms of basically how much is one pixel. So for simplest case, I've kept it as like 100x image. This is the reference image. Here, one pixel will be 1 nanometer. And if you multiply it, it will be 10 times this 10 nanometer in this one. Okay, because this it is 100x image, this is 10x image. So over here, one small pixel is 10 nanometer. Here it is 1 nanometer. So this pattern is shrunk almost like 10 times. It will look like this. And so you will see almost like 100 like patterns here. Now coming to the data set itself, if you see this data is prohibitory to many customers like who are creating chips, memory or logic. So we can't publish real images which we work on. or customer shares with us, or we go which has present on tool. Even customer has basically we don't they don't share it with us also, some of them, and some of them we work with them together. So ideally what we expect that there are papers or literatures which are published already, and wherein you can create such data sets like the ones which I created. These are created by Claude or maybe by Gemini, and you can create your own custom scenarios. How to create it also, I have a dedicated section wherein I will talk about it. But at this stage, I want to take a pause and take some questions about what are you clear about the problem, like what you have to really do. You will have two pairs of a pair of images. One would be a reference image and one would be a wide search image. You have to search this reference image in the wide search image and give us the coordinates in terms of pixels to the nearest one to the center. Is this high level clear? We'll touch more about it in the coming slides. But is this problem clear to everyone? Can you give thumbs up? That will give me some confidence. Is it clear? You can always ask that to repeat in chat. Not clear. Okay. Yes, sure. So as an input, you will be always given two images. One is one is a search image, and the other one is a, yeah, please, I will repeat also. Sure, sure, I'll repeat. So in the left side, you have a star image, the reference image, which we want to search in a zoomed out frame. So if you see this, this actually is a zoomed out area, and the same pattern exists here at the green area. When I go and zoom in, it will look like this. So when I look at a location with a 10x zoom, I will see this kind of image. But the same location I see with 100x, I will see this image. Just like I showed you the initial map, how do we search in a bigger India map of a given location? So same way we are trying to search the image on the left, on the right side. So a naive example on approach, how would you do it? I would basically compress this image to a smaller times, that is 10 times. So every 10 pixels here, 10 by 10 pixel would be a 1 pixel. I will try to compress it and then make a smaller image and then search that smaller image inside the big image. This is what you will do, right? This is a very basic brute force way of doing it. Siddharth also has a question. Siddharth, you will always have guidance from us, but try to keep it as, let's say, a simple nature. Like if you have, it's a pro algorithm problem also. If you want to compress something and search it in the bigger image, you can always do it. Like it's a matrix problem, right? You have a bigger matrix, you want to compress it by some mean, and then search it in the wide, bigger matrix. If you treat it as zero and ones, even that is one way of doing it. Okay. Yes, you will have the recording.
Okay. Only technical questions, please,
Yeah.
right of now. As of now. Ayush, sir, you can continue. Yeah. Okay.
Yeah. I I think so. We it's a so far what we have explained. We will talk now about the expected solution in depth. And but I expect you to try it. Take help from AI sources, and from us also you will get support how to run it. So try to understand the problem at this stage, high level, and see your interest in it. And remaining help will come. So first, I want to talk about the data sets. How do we create such data sets? So it is, yes, Nikhil, you said something similar, but you have to compress A here. Yes. Okay. So now let's say, how do you want to create? First of all, you can't create any polygon. Like the one I created has some meaning to it. It will look like some cells, how it look like. You can't create something very random, which is like doesn't make any sense, some integers or something. So you need to basically have some way on Gemini or Claude or whatever AI, GPT, whatever models you have, you want to do some sort of a learning. We want you to spend some time on literature. And let's say these are one of the recommended literatures. I will give the slide as well. You will have videos also, and you can take a screenshot also. So these are you can say top public papers from which you will have some images, PDFs, which are published. And with that, you can ask your AI model to basically first create some synthetic code which can create some images like this. Okay, so you can have some Python code created which will create images like this. Read about how logic and memory structures are created, how these circuits look like. You will have some papers around it, and you will be able to create it. Okay. And we will also help you with some data sets. We'll help you with some prompts, with some scripts, which you can use to create data. Okay. But we would like you to try some, create some data sets like which I have shown some examples here. Where you ask something which is purely algorithm. So yes, you can, it's on the similar lines what you have mentioned, but not exactly correct. But you, in the direction wise, you are correct. In the what approach wise you're saying, it should be something similar. So somebody asked about pattern rotated will be symmetric. Should we consider on the upper triangle but match it? No, no, we'll talk about it. Hold on about the pattern part. So now let's see about the synthetic data creation. So first part I talked about how you should basically create the whole layout, like the one which you saw some layout which looks interesting to us. How to create repetitive structures. So let's say this icon is four circles, but you see there are many circles. So there is some pattern here in between which is helping us to find it uniquely. But if this is not there, you can register, you can basically find same locations, different places. But in that case, if you have same location, you find something closest to the center. Okay. But in this case, it's purely unique because it has some white and black rectangles, which basically forces us or to find it only in one unique location. This is on repeating part. So you try to create repeating areas because when we will also evaluate, we will also give repeated areas in the image so that we see that how your algorithm works. In terms of, let's say, in terms of did noise part, let's say now the second time is like you have what you see here is there is no noise as such, but there is some noise in this image. So what we want is to add some noise. So you can read about what distortion does to an image. You can, if you Google distortion in images, it will show some polygon edges are distorted. It's like old televisions, you will see some screens or polygon or shapes basically getting misarranged. That is more you can see some reference from that. Then there is a charging. Charging comes because your edges will become, you'll have some different noise around on the edges. So you see about the charging part. Now there was a question about rotation and symmetry. So the symmetry stays as such. The patterns are also Manhattan pattern. That means you will have circles, you can say squares, you can have polygons which are very shaped, but it will not be, let's say, some hand-drawn polygons. Okay, so it is not like uh, sorry, not like medical images which have like tissues and bones and all which are like asymmetric. It is very, you can search for a term called Manhattan. Manhattan means like everything is crisscross 90 degrees at a predefined angle. Okay, it is not like a non-linear pattern. Okay, then the question came is whether it is can be rotation. So if you remember in the video I told you that in this video we saw that at some places the stage can have show an angle. Okay, because of that you will have slight rotation, but not too much. So now coming back, so you can have only 1 to 3 degree. So when you're creating synthetic data set, maybe this line when you're drawing, you can move either one of them by 3 degree, 2 degree, 5 degrees. So try to add those things and see how your algorithm is robust to this kind of data. Okay. So right now we are still discussing. Arfa has asked, will be getting 2 images? Will they share us, or it's a download link? No, you are creating data sets as part of this. We will give some images somewhere in middle, but as of now, you should start creating data sets based on what we are talking right now. So that's the reason why we are trying to say that see more on, hear more me on this, and then we'll talk about how you can create. So you can rotate lines angle at some angles and see how. And all of the code you can use Gemini and other methods to rotate it and see, observe it with your eye that it is doing justice or not. So we don't expect that you learn every part of this. You can see visually and add noise and see that yes, the noise looks real and how it shapes. But focus more on the first line. Try to understand the architecture, technology, logic, memory, so that you can create right images first of all. Then the second steps are easier because then you can add repetitions, you can add each polygon, you can add some distortion, you can add some charging, you can add some rotation, and same way you can add some scaling. Scaling means I can reduce the scale of the circle, reduce it by 20%, increase it by 20%. Because these kind of issues can come. That okay, one of the polygon in this angle of when you're taking it over here or versus here could be small or big. Okay, so this diverse data set you can create by scripts. I also created this, let's say within few minutes with some prompts. So all of these are generated by me, and it's no spatial scale as such. You can use Gemini to create such data set. I will talk about it how to create it also. Okay. So there are some literature which you can either read it or you can get it proofread by Gemini and ask Gemini to find it for you. Take screenshot of this. It could be one of the reference, and then make prompts accordingly to create different kind of impair images, given the problem status. Prashad, we will talk about it. Okay. So first part we talked about create a data set. The second part is how to add noise. This part also we added. Okay. How to take this. You have papers, textbook, patents available online, and then you can add it. Are we clear up till this? Then I will talk about the algorithm. Anyone can give thumbs up. I see a raised hand, Shubhangi. Mm. You can start with, first of all, let's say somebody asked the question that should we generate with sharp boundaries? Having justify first the sharp boundary is giving you a good confidence. After that, we step by step add a noise. So I will come. I was coming to that part. Um, so let's see. So ideally, there's something called as PR noise study. So when you have low noise, everything will look very nice. That's a good world to be in on the top. Okay. And then once you start adding noise, these kind of augmentations which we talked about, you will start seeing some drop in your PR curve. Your F1 score will drop. You can read more about PR part and then learn more about precision recall. So this is a step study everybody should know when he's working in machine learning algorithms. You should these are fundamentals and from confusion metrics, and you will see that adding more noise should basically drop down your accuracy to some extent, and you will not do well. Okay, so this study is something which you will do. So ideally, what you ask question that if I make it sharp, yes, you should make SHA first, and then try to see your algorithm works on it, and then keep on adding step by step different kind of noise and see the behavior. So it will never be a problem that you dump this data, this video or this presentation in one prompt and expect a solution out of it. You will have to work this problem with allocated time and learn each step, and then you will be able to solve this problem, because it's a good problem to solve and every step is important to understand. um, okay, so one magic wand will not solve the entire problem. In this case, like any other machine learning problem, it requires a step by step approach. Okay, so now the main part here which we talked about is the 10x image versus a 100x image. So you need to find, let's say I will go to a dedicated slide for it here. Sorry. So first, let's say I'm finding this image inside this image. Okay. Maybe you can do 1 pixel error, 2 pixel error, 3 pixel error. Both the images you are only generating. So you know where exactly you have placed the pattern in this image, right? Once you create this image, you create this image. You know where exactly this image is supposed to be found. So you know what is the exact coordinate. Then you will create a model which will find it inside this. And then you need to see how much is the error. Is it 1 pixel, 2 pixel, 3 pixel, 5 pixel? So with that, you'll come to know that, okay, how good your algorithm is, that it is capturing exact spot or it is making some slight errors. Slight errors like 1 to 5 pixel is a good model. So, but we want to see how good it is, and we want to see this confusion matrix as at different. So we'll give a utility to basically produce such matrices. So given a two pair of images and your algorithm, it will create a confusion matrix at different pixels, and that's how the PR study comes. General conception, like generally when you have a classification problem, so you have one binary class, right? You create a class that, okay, yes, at this class, if you're doing like cats versus dogs, so you're saying this is cat and this is dog, and you have some confusion matrix for it. But you can also say that my cat, I will approve only if it has a score of zero point 0.9 or zero point 0.8 or zero point 0.7. So then you basically have a threshold at every level, that, okay, at what level I'm getting a good result. Okay. Am I capturing all cats at zero point 0.7 or zero point 0.8 or zero point 0.9? So the same study is applicable here also. In that threshold is your pixel. How good your model is in terms of pixel accuracy. Is it correct? Did everybody got the point? So let's say if you're finding whether in the image there is a cat or not, I'll simplify. And you have a model which is giving a score between, let's say, 0 to 1. If it is zero point 0.5 above, you can say that yes, anything above zero point 0.5, I will say it is cat. But it will create some, you can say, false positive. So you will increase the threshold. You can go to zero point 0.6, zero point 0.7, zero point 0.8, zero point 0.9, depending upon how good you want to network. So suppose you don't want to miss out on any cat, you will reduce the threshold to zero point 0.5. Suppose you want not don't want to make any error, so you will increase the threshold to 0.95. So whatever you are saying cat is surely a cat. Same thing is here. If you want to make a threshold at 1 pixel, that means you don't want to make any error. If you want to make 5 pixel, it's like you want that, okay, yes, at least I found some location which is close to it. So that is a liberty you are giving at confusion matrix. Does it make sense? You can put it in GPT also, or maybe AI chat bots. They will explain you in depth how this works. Hmm. Please type message here. Okay, I see some messages are there. Sir, can you explain DRAM and like what's the difference between two and above? And but this is a very big topic to close in 1 hour session. I'll suggest you read about it. DRAM and FinFET is like part of your CPU and RAM, which is there in our laptop. And you read high level how they look like under microscope, specifically in the SEM microscope. I'll flash one prompt now, and that will give you some idea. Second. Maybe you can take a screenshot of this prompt. This I initially shared. So now maybe the question people are worried more about the data set itself. So don't think much on data set. You can work with this problem with one image also, right? So you can have the image pairs which are present in this is presentation. And you can also enhance and create something similar and start. Yeah. Swapnil asked what is the approximate nanometer to pixel ratio. So I mentioned it for your reference. One pixel is 1 nanometer in 100x image, and in 10x it is becomes relatively same 10 nanometers. Okay. So you can ask the prompt. You should give this information. So Swapnil asked this question. You should give this information in your prompt, telling him so that the AI model also knows that what kind of image we should generate, because it will have some knowledge about these data sets. And then you can give the citations which I gave. So in this also, if you see, we are asking it to create navigation error problem. We are giving some context. You can give the problem PPT also, or maybe the text. And then we are asking it, okay, you want to work with 1000 by 1000 pixel images. You want to work with DRAM and FinFET. You give some sort of arrangement, and then you ask it like, okay, I want to create something which is the 10x physical field of view and something at 100x field of view. Okay. And then at the same time, you ask it to add more grayscale noise on each image. Don't use same noise on both, have different noises. Add it, mimic it to how same images should have brighter contrast around around the edges. And then save the images, and you want to confirm it had side by side, mark the center. So all those things you should do. Yes, Tony, you're right. Very simple. You got it exactly right. So you want to create an image and then a downsampled image, or you create a big image, find a pattern and upsample it. So up to you. But I'll suggest it the first way. Uh, and this is one of the sample prompt. You can extend the prompt by adding citations, make it more complex, and be very patient. My suggestion is don't try to assume that it will work first out. You have to mature your prompt and then do it. But it is doable. If we can do it, you can also do it. It's because both are using AI to generate the data. Okay, but have patience to do study. Now, once you do that, you create the confusion matrix. And let's say two algorithms approaches, the results are matching. For example, confusion matrices are matching. Then what is the secondary evaluation criteria which we will use? Secondary evaluation criteria would be computation time on a single pair of images. Okay. And then you can report, you will generate a lot of test samples. We want you to give your best 30 samples, justifying that, okay, what is unique about this? So now you see here, this pattern, you're searching in this pattern, right? So what pattern you have a reference, you can reuse the same image on a different pattern. Let's say you can create some circles here around it. You can keep on changing your wide search image, but you can reuse your reference pattern. So this is allowed. You don't have to create both of them unique. You can have same reference, change the right side. You try to find the same pattern on some other different layout. So this freedom you have while generating the data. But you give us top 30 samples, which you feel like where algorithm have was very uniquely tested, and you feel like, yeah, this is a good case. So as an algorithm engineer, everybody wants to justify their algorithm, and we want you to express in the same way, saying that why your algorithm is unique and different, or maybe very robust to others. Okay. So this is one case. This is very important that you justify your top 30 sites with your augmentation and your results on it. We don't care that the results are average or bad, but if you've generated very good data, it is also a very good property, or you can say very skill, very much needed skill for somebody who's working in algorithm domain to create a just data set which is very challenging. And also, we want you to justify out of them one at least good failure case, like one good failure. Maybe you have solved it, but maybe you should justify one good failure case. I gave an example. Let's say you have very highly periodic. The same pattern is present in multiple places, but you found a unique way to handle such case. Maybe you used a closest to center approach. Maybe you used a way to suppress one of the signal. Uh, and how do you do that? You have some cross correlation methods. You move to a different domain. Uh, can you, how do you justify a failure case, and what was causing it? Maybe you added too much noise, you must added too much of distortion, or added too much of scaling, which caused where your algo starts breaking. That is okay. If you have understanding about what your algo cannot do, that is also one of the key strengths. It's not like it's not working. We want that it should be. There's a question, is computation time measured per single image? It should be measured per single image. We will keep it simple, not GPU, CPU. We'll keep it simple. But if you want to have a GPU based algorithm, you want to split it, you can mention your approach, have a separate submission for that. Let's say you can say that this is my basic Python file function which does works on pair. But if you want to parallelize it, let's say you want to solve the problem by dividing into batches and then attack it, which will give a throughput improvement on many places. Let's say if you try to do it with batch, and overall you can, let's say you're doing with 10 pairs and you want to use a GPU and you can bring it down. That is also a very good solution. We will respect the computation time in that. But first is like the approach itself. The confusion matrix should actually look decent. So as such, as again I'm saying, there is no, it's not a classification problem like yes and no. So you can have 1 to 5 pixel of error. You can even have bigger error depending upon how much noise you're adding, but you should be able to justify it. Okay. Okay. So now let's talk about some fundamental questions which may come. So let's say, what is the image size? Both search and reference image is 1000 by 1000 pixel. This is very, very important, because if your algorithm breaks while our test, which we will create some, you can say, modules to verify it automatically. In that case, it may pose a problem. So let's try that whatever images you are creating, you have a validation block that it should have 1000 pixel by 1000 pixel. So this is a part when you're creating a data set itself. And to verify that your algo works on 1000, you can have an assert also. Then submission format. So what we want is like you zip your file. You may have many environment dependencies. See what is relevant. Give us the condensed version of your environment dependencies with including the Python version, and then a documented file with the data set you created with noise modeling method. So let's say you create 30 images. You try to give a Python file which can create those 30 images in a sequence. You can have, let's say, some method which is like reference 1, 2, 3, 4. It is creating all 30 pairs. Okay. And we will basically analyze using a documentation that, okay, what exactly you try to do that. Try to have some explanation towards it, towards your code or to method. And you can also have a supporting document to justify your choices for dataset creation. Then comes the third part where we say that you give a Python file with a given function name. We will throw you the function name, and which will give the XY coordinates in pixels on a wide search image for a given reference image. So you will get, and you will have to find something closest to the center, as we discussed. Then if you have a DL method, we encourage people to use DL method. Classical is also one way to do it. DL is also, there are many architectures with, you can try with Dino, you can try with the YOLO, you can try with other methods which are state of art, and we are very we can be respectful towards unique approaches. Feel free to try. Different approaches, and if you're having a DL model, give us the DL model with weights and the training notebook also to explain the training process with documentation. And any documentation with respect to citations or methods you can mention here, like why you feel this approach is. So this is your submission zip. Okay. Avnesh asked what should be the size of data set to be generated? At least 30 samples, good samples you should generate. Okay. 30 good samples. And believe me, the samples which are mentioned here, I will not. These are like created in few minutes, so you will have to step up from these samples. This is only for explanation. So the new samples or new code will give or prompts will give to generate. It will create more complex cases. Okay, I will talk about it. Uh, can we submit code in C++ or Jupyter Notebook? So it's our irony that we don't want to take it in many languages. We'll keep it simple and flat because if you give it in C++, then it will not be fair for other people who are working in Python. So let's keep it very same. Try to give it a pure Python code, not a Jupyter Notebook code to because the computation time also matters. So one straight shot of Python execution with the input images will give us exact time, and which with which we can basically say that yes, this is his expectation. False, we can match one on one. Sure, we will share the PPT. Uh, Now, which noise models we should use? So again, you should basically refer to the what in addition to what we had. You can read more about SEM images. These are scanning electron microscope image models. Most prominent of them is like short noise. You can read more about it, distortion, scaling, and other things, and accordingly add more noise and justify it also. Like, okay, are you close to it? Okay, and also you should assume that the wide search image you're taking it from a zoom out. It will not be very clear. Like you take an image of a distance, it is more noisy because it doesn't know where to focus. So it may focus something on the immediate, which is very close to it. And let's say there's a pole and you're taking an image, there is a background mountain or trees behind it. General trend of our cameras will be to focus on something nearest block. So same thing can cause in any camera, and even in SEM also, there are a lot of other noises. Like you can focus on area and other areas in background may basically cause this issue. So someone who is like assuming this kind of assumptions and creating data, they will have, let's say, better real life scenarios, and with proper justification, they will be much more appreciated or ranked. Okay, so I will come on the sample data part. We already discussed that you have scaling, you have a starter prompt we have shared. We shared you some citations to create look for web articles, and we'll try to give you some with the local group here, which we have supporting this hackathon. We'll try to create some GitHub repo with some samples or uh, with code samples, or maybe directly the prompts itself, which you can try. So this is something which will open to Saurav, and Saurav will share it with you. How is the final scoring? Because this is very important, and everybody thinks like, where should I focus? So first of all, like the augmentation is very important. It will give you 30% weight, and it is something which, if you read more, learn more, everybody can use and have a clear shot at 30%. Okay. 50% is on the inference result on exact confusion metrics, how basically we compute it, finding the current coordinates at different. We'll see how stable is the algorithm in terms of confusion metrics at PR curve, which I was showing. Also on terms of pixel level error when adding noise. Uh, and in addition to that, you can say that 10% last 10% is on this, and 10% we will say that we'll keep it reserved for something which is like unique in the. So I'll add here is like 10% is something which we will evaluate on overall explanation part. So I missed to add that one. So remaining 10% is on the explainability of the cases, and 10% is on the failure cases. So whatever you've done, can you explain, presentation will matter. And the bonus marks, if somebody can do it for RGB images also. So this is something you can, so same image, if you take it in optical tools, it will be RGB images. Can your solution work on an RGB image also? So can you attempt it? So it's not of in the 100, but it will give you some bonus. So if you are doing some less on other parts, bonus, or let's say 10 marks, we can give it for bonus, and you can have that bonus also if your same solution can be scaled to RGB images also. Okay. I guess on the evaluation rubric part, I covered the percentage. So we will give a scoring utility, and you will have you give a list of pair of images which has CSV of wide image search path, reference image path, ground truth on the wide search image, and this is your input to the scoring utility. It will publish the metric, and with 1 to 5% accuracy will give you some plots, and that plot is something you can add it to your submission so that everybody is presenting in the same format to us. So we be very fair to all people. So it's like somebody is giving a confusion matrix, another person is giving confusion matrix. The question may come is like, are we being fair to him? So this utility will make sure, because this is our utility, somebody from us will write it, and it's very clear how we want to evaluate it. So we'll see the images, we'll see the confusion matrix, how it looks like for different noise levels on your data set and our data set. And with that, we can conclude it fairly for all people. So it will be purely fair how we evaluate the process. It's very transparent. You will get the scoring utility code also. No questions there. Okay. And we'll try to give you more synthetic images builder prompt. I keep on saying it because I want you to attempt this problem. It's a very good problem at academic level, and you should definitely try it. Um, yeah, I guess that's it. I've covered almost everything. Let's open it for more questions if somebody has. I've covered everything. Yeah. Saurabh,
Yeah.
so you can give thumbs up
Thank you, Ash.
if you like the problem, and ask questions now.
Yeah. The problem statement is actually quite interesting. A lot of different type of concepts to be involved, like AI models. If you have any questions, please put it in chat box or raise your hand.
There's a question that can we use Kaggle dataset if we open licensor? I'm not sure you will have a Kaggle dataset on such use case, but you can try. I'm not sure you will have zoom in, zoom out case. What kind of source use for training the ML model? Yeah, so when you're creating a dataset, let's say I created this dataset. Okay. So when you will create a dataset, you will ask your model to place it somewhere. Okay. And then model will basically, you'll have a script to create it. Don't use generative AI to. Hello?
Yes, yes.
Somebody's talking background. I don't. Yeah. So somebody asked about how it is stored. So when you, so I'll try to be very clear. Don't give Nano Banana or Gemini or OpenGPT to create images for you. Ask it to read the literature, give you the Python code with all these things, and then generate the code. Then generate these files so that you will know exactly what logic was used to create these images, and also you know what is the ground truth at pixel level, because you place this at this location in this image and you will have the XY. So final CSV which you have for training an ML model will contain at what location you kept it. Let's say here. Yeah. So I kept it like final CSV will have the paths and will have ground truth X and X and ground truth Y of that tile where you place in the wide search image. Is it clear, Mahalakshmi? Can give a thumbs up. So you can always start with the images here. Okay, we'll give you more images. Well, once from our side also, this was just a, you can say, starting kickoff webinar where we wanted to explain the problem in depth. And now we'll be more hands-on with you to help you out.
Mhm.
If you have, there was a question about DRAM and FinFET. I'll suggest like read about it, and in between we'll try to have some discussions to talk more about it. Let's say if you have some questions on case to case basis, if you share some images with Saurav or us, and if it has needs some corrections or we can talk always about it and we can try to explain. Any more questions?
Mm.
There will be a benchmarking. Um, so I really will share this slide, and this contains the rules. In terms of benchmarking, we will give you a scoring utility, and the scoring utility will give you the wall time as well as the results. These results you have to provide it to us. At first level, we will first of all we will see the images, and second level we would like to see the results are using our scoring utility. Okay. Yes, Mandeep, we will share this PPT. Don't worry. Don't worry about the document.
Yeah. Yeah. If anyone has any technical questions, please put it here,
Yeah.
or you can raise your hand and then uh, like unmute yourself and then ask if you have any long question you asked.
Is model size and inference time on the evaluation criteria? Yes. So model size, I'm not sure how heavy a model would be, but it should not be so big. Let's say I'll try to keep it simplified. But inference time is that it should not take several minutes. Okay. And model training time also you have to share the data with us. Like that's the reason why I've asked the notebook, because the notebook which we say here, the DL based method, if you have, let's say I've asked in the FAQ section, I'll jump to FAQ. Yeah. So in FAQ, we have mentioned the DL model and training notebook. So this will help us to understand how heavy your model is, how many parameters it has, what is the architecture, and how much training time does it need, and what data you have used for training. How much percentage of noise we can add to the data sets? This is a good question. So you should start seeing when you keep on adding noise, you will see some PR behavior. So as soon as you keep on adding noise, you will start seeing some drop in your results. So in your score. So you play with it and see that how bad image is, and then you can say that yes, see my algorithm. If I add on this kind of noise to my shapes, let's say on these lines, still my algorithm behaves, or you can say gives this kind of accuracy. So what will happen? Let's say I right now, if I add too much noise to the image on right side, and let's say I'll take a zoom here. Okay. So now if you see, if this one line over here is 10 nanometer, okay. If I register exactly right, I will get the box right. But if I make a error of 1 pixel, that means if I make this particular line, let me take uh, I'm not getting it. So if you see there are vertical lines here, and okay, so in these vertical lines, if I make 1 pixel error, I will have a shift of 10 nanometers. It's bad, right? So how much is your algorithm good? You can have a range. I've suggested like 1 to 5 pixels. You can have 10, 15, 20, 50. First learn. First, we want you to solve the problem. Then we will start working with you to how to improve the accuracy. Atima said, yes, there is a 10% part. See, model explainable fetch is always the bonus point. If you are not able to, because at the end, the winners also have to explain their approach. So you, whatever you're doing, you have to explain it. And it is part of the marking process also. That's the reason why we are saying that have a proper documentation around the approach, not a AI based documentation. Even if you're generating in AI, make sure that you read it.
Yeah, definitely.
Any more questions? How much we can add it based on ourselves? How much should we add repeated patterns across your matching, sir? Alpha, we leave it to you. It's not like we'll not have, you can say that one predefined use case that you should have minimum this much. We will also share some validation data sets to you. You can have some reference from it. But it's like you should see from your algorithm design point of view. You want to see that how you see that, okay, can my algo help this? So that brainstorming, we leave it to you. Can it work in this case? Can it work in this case? This is something we want to see your imagination here. Can it work for repeated patterns? Can it work for if I add this much noise? If I remove these many pixels, how it will look like? If I add some particle here. So all those things we leave it to you. Beyond achieving high accuracies, what qualities would make teams most valuable? Applied. So first is like we'll talk about accuracy part, and then we talked about explainability part. Then we talked about computation time. So these three are the top metrics home which we would like to hear. Uh, then obviously the people who are coming in top 10 or top 5, as which Saurav and team will decide based on our evaluation. They will present it, which will basically the judges over there will decide. In real world, the
Yeah.
complexity of the problem much higher. It would be great to hear from importance, wafer and pattern matching and process control. Yes, but it will be somebody has mentioned that we would like to know more about its importance, wafer die alignment. But most of the content, like I've tried to touch in brief about it, you can also read about it. It's like this kind of the papers or literature, if you'll try to read about navigation, if you give this problem and try to understand, there are several patents on different approaches. Most of them will not have disclosed it, but they have given some methods and take patents or published papers around it. So that every paper will talk about the background. So you can see from what are the complexities, different. But I'm just saying that don't try to digress from the core problem itself. I try to give you the fundamental, and this basically field is very huge, and that's why we are only talking about a very narrow subset of a problem, so that it becomes, first of all, we want to see that, okay, can you solve a imaging problem? This is the reason why I mentioned in the first slide that's an imaging problem. So I will say that you understand more of the process side, the how these images will look like on a pattern on a wafer, and try to solve the algo problem. And if you get time after that, maybe you can learn more about the background of the navigation problem. Picture you are showing, if we can produce the bonding that's near to that defect. Uh, so this is not a defect here, okay? This is some pattern which is circulating. So let's say I'm searching this plus sign. This plus sign on this image could be at multiple places. In this image, it has created something like this. But if you see your network or your model is very strong, it will capture this small plus also, right? This one. And some structures will fade away. If you see, This dot is just 1 pixel. If you see the image, maybe the team sharing will not allow it, but it's very few. See if it has been condensed so in a different way, and you will see that you have this line. It can register here also, but the center pattern is missing here. So it found a place here. Maybe image center is somewhere here. So you have to find something close to here, not up, not down. You have to find this green box is the closest to the center of this image. And you have to give this is 0, 0. You have to give XY here. Okay. It is very nice problem to solve. And you can solve it with maths also. It's a pure algo problem. Uh,
Yeah. Okay. If we have any further questions, we can take it offline. You can write to us on our email ID, which is there on the landing page. First, I thank you, Ayush sir, for answering for this insightful presentation and explaining the problem statement in depth and answering the questions from the participants. A few more details to participants, like carefully review the complete problem statement that is given on the landing page. Each and every detail is there. The problem statement, the background, the description, what is all required to be submitted. Um, Also, the PPT is made available on the landing page. Now, the updated PPT will be made available on the landing page. So there is a dedicated section in the problem statement. Under that, you have a problem download PPT section where you can download the exact PPT that is presented right now. Uh, Another few questions that participants had. Uh, so that a participant can register as a team captain and they have to participate in a team of 2 or 4 members. So the first phase deadline is 16th of August. So try to give your solutions, work on them before 16th of August. We'll be doing one more session for to to take on the Q&A with questions that you have or issues that you have faced. Uh, Maybe in next 2 3 days of building the solution. So we'll be taking one more Q&A session in next week. Um, okay. Also, we have given a submission template as mentioned by Aisha, like you have to explain how you are solving your problem, how what approach you're taking to solve the problem. Uh, so we have given the submission template on the landing page also. I'll just give you a glimpse of that. Okay. Share my screen. Okay. The such kind of template is made available on the landing page where you we have given you the all the instructions, which is similar for the both the problem statements. So you have to give your details of the college problem statement that you are addressing, then the description or the how you're approaching the solution. Are you sure you're on mute if you want to say something?
no, I'm not saying anything. Thank you. Please continue.
Yeah, so I will take care. So propose solution, then what uniqueness or innovation you're bringing to the solution, impacts. So technology and the methodology you are using. Links. So whichever the documentation link, so GitHub link or video link, your explanation of the solution. If you are willing to share it, share it. So GitHub link is very important, as mentioned by Aisha. You have to share the Python script and all that, and the references that you're using. So this all will help us understand how you approach the solution. This is also important, along with the other required documentation to be shared as mentioned during the session. Okay. You want to add something, Aisha, or we can conclude? You're on mute.
So, yeah, maybe sir will talk after this once you close the recording. You and me.
Okay, then we will conclude. So on behalf of the organizing team, I extend sincere gratitude to you, Mr. Ayush, and a team from Applied Materials for giving this problem statement and presenting it today. Thank you to all Semi India members, IESA, KL, Applied Materials, KL, and VIT members who are part of this organizing team. And thank you to students for participating in the hackathon and today who joined the webinar. Hope this session have given you clarity and a technical direction to start working on the solution that is required or to start working towards solving the problem. And we look forward to receiving your solutions. Thank you. The recording will be made available on the landing page. Also, you will receive an email uh, with the same. Thank you.